Hi, I am Mohit Agarwal. I am PhD student of Benin. I am trying to explain TensorFlow. I will start with a comparison of TensorFlow with NumPy and move to some examples of TensorFlow. What is a TensorFlow? TensorFlow is a deep learning library. It is recently open sourced by Google. What does it actually do? TensorFlow provides primitives for defining functions on tensors and automatically computing their derivatives. But what's a tensor? Formally, tensors are multilinear maps from vector spaces to real numbers. For example, a scalar is a tensor, a vector is also a tensor, and matrix is also a tensor. Common to a fixed basis, a tensor can be represented as a multi-dimensional array of numbers. TensorFlow versus NumPy. TensorFlow and NumPy are quite similar. Both are n-dimensional array libraries. NumPy has ND array support, but that doesn't offer methods to create tensor functions and automatically compute derivatives. Simple NumPy recap. To use NumPy, we have to use import NumPy as NP. If we do A is equal to NP dot zeros 2 comma 2, it will create a 2 by 2 matrix with all zeros. And if we do B equal to NP dot ones 2 comma 2, it will create a matrix of size 2 by 2 with all ones. If we do NP dot sum B comma X is equal to 1, it will sum the values in the vertical direction and give us a vector of values 2 comma 2. And if we do A dot shape, it will tell the shape of the matrix, which is 2 by 2. If we do np dot reshape A comma bracket 1 comma 4, it will make a single vector from the 2 by 2 matrix with all zeros. Now if we compare these operations in TensorFlow, to use TensorFlow we have to use import TensorFlow STF. To make the calculation in TensorFlow we have to initialize with tf.interactive session. And if we do af.tf.zeros 2 comma 0 2, it will create a matrix of 2 by 2 with all zeros. Similarly, b is equal to tf.ones 2 comma 2 will create a matrix with all ones. tf.reduce sum b comma reduction underscore indexes equal to 1 dot eval is needed to print the value. We cannot print without eval in this TensorFlow. Reduction in underscore indexes is similar to x is equal to 1, and it will show the array of 2 by 2, 2 of 2 comma 2. Similarly, the shape we have to do a dot get underscore shape, and it will show that it is a tensor shape with dimension 2 comma dimension 2. We can reshape our TensorFlow also using tf dot reshape a comma 1 comma 4, and dot eval is to show the values. So the A matrix which we reshape to form 4 comma 1 matrix, 4 comma 1 vector with all zeros, 0 0 0 0. Now comparison of NumPy to TensorFlow dictionary. NumPy, if we write a is equal to np dot zeros 2 comma 2 and b is equal to np dot ones 2 comma 2, in TensorFlow we will write as a is equal to tf dot zeros 2 comma 2 and b equal to tf dot ones 2 comma 2. In NumPy, if we write np dot sum b comma x is equal to 1, in TensorFlow we will write tf dot reduce sum a comma reduction indices equal to 1, and in NumPy a dot shape will be same as a dot get underscore shape in TensorFlow. In NumPy np dot reshape will be similar as tf dot reshape in TensorFlow, and np dot a comma b will be same as tf dot matmel a comma b in TensorFlow. And other operations are similar in like a accessing the index I comma j will be similar in TensorFlow with index I comma j. TensorFlow requires explicit evaluation. If we are having a NumPy array of 2 by 2 with all zeros, in TensorFlow we can have similar matrix of 2 comma 2 with all zeros. If we do print a in NumPy, it will simply show the matrix, but if we do print ta in TensorFlow, it will not show the matrix, and we have to write print ta.eval function to show the matrix. TensorFlow computation defines a computation graph that has no numerical value until evaluated. TensorFlow session object. A session object encapsulates the environment in which tensor objects are evaluated. If we write a equal to tf dot constant 5.0 and b equal to tf dot constant 6.0 and do c is equal to a into b, then we have to write with tf dot session as scss print scss dot run c and then print c dot eval. So these operations are needed to start a session of TensorFlow, perform the operation of which has been defined earlier, and then print the value using eval. TensorFlow session object. TensorFlow interactive session is just convenient syntactic way for keeping a default session open in IPython. Session.runC is an example of TensorFlow fetch. TensorFlow variables. When we train a model, we use variables to hold and update parameters. Variables are in-memory buffers containing tensors. All tensors we have described previously have been constant tensors, not variables. TensorFlow variables. If we create a variable, if we create a constant w1 equal to tf dot ones 2 comma 2, it will create a 2 by 2 matrix with all ones. But if we want to create a variable w2, we have to write w2 equal to tf dot variable bracket tf dot zeros 2 comma 2 name equal to weights. Now it will be a variable form which will have initially 0 values, and if we want to perform some operation on w2, then we have to write with tf dot session as scss print ses dot run w1. So it will print the value of w1, and then if we write ses dot run tf dot initialize all variables and then print ses dot run w2, it will print the value of w2. Initialize all variable is the step, initial initialization step, in which the values of the w2 will get initialized. TensorFlow variables must be initialized before they have values. Contrast with the constant tensors. If we are having a variable w equal to tf dot variable tf dot zeros 2 comma 2 name equal to weights, and r is equal to tf dot variable tf dot random normal 2 comma 2 name equal to random weights, then we can do with tf dot session as scss ses dot run tf dot initialize all variables. So it will give 0 value to the w matrix and some random values in the r matrix. Then we can print the w and r matrix using print scss dot run w and print scss dot run r. Updating variable state. If we are having a variable state equal to tf dot variable 0 name equal to counter, and we do a function which is new value equal to tf dot state add tf dot add state comma tf dot constant 1. So what it will do on session dot run and then update equal to tf dot assign state comma new value. So on session dot initialize all variables, it will initialize the variable state with the value 0, and then we can print it, and then for any variable in range 3, it will call the function update, which will add the value 1 to the variable state and print that value. So we will have 0, 1, 2, 3 as a print of the small code which is shown on the screen. Now how do we fetch variable state? If we are having a constant input 1 equal to tf dot constant 3 and another input 2 with tf dot constant 2, another input with tf dot constant 5, and we define an intermediate with tf dot add input 2 comma input 3 and mul equal to tf dot mul input 1 dot intermediate. So what we will do, we will do tf with tf dot session as sesh result equal to sesh dot run mul dot intermediate. So it will first calculate the intermediate value with adding input 2 and input 3, which is 7, and then multiply input 1 with this. So we will multiply 3 with 7, which will give 21. So it will print the two values 21 comma 7, because result is equal to sesh dot run, and in brackets, square brackets, we are having mul dot comma intermediate. To show it as graphically in a graphical form, we can say input 1 equal to tf dot constant 3, input 2 equal to tf dot constant 2, input 3 equal to tf dot constant 5, then adding the intermediate for 2 and 3 and then multiplying it with intermediate with input 1, which will give null. Inputting data. All previous examples have manually defined tensors. How can we input external data into TensorFlow? Simple solution, import from numpy. So for example, if we create a numpy array with all zeros, then we can convert it into a TensorFlow. For example, if we have a TensorFlow constant TA, then we can convert the numpy into TensorFlow using tf.convert to tensor and in bracket a. Then with tf.session, if we print sesh.run TA, it will print the 0 matrix, which is size 3 by 3. Placeholders and feed dictionaries. Input data with tf.convert to tensor is convenient but doesn't scale. Use tf.placeholder variables, dummy nodes that provide entry points for data to computational graphs. A feed is a Python dictionary mapping from tf, placeholder vars or their names to data, numpy, arrays, list, etc. Placeholders in feed dictionaries. If we are having a placeholder input 1, we can write input 1 equal to tf.placeholder tf.float32 and input 2 is equal to tf.placeholder tf.float32. So it will create a placeholder which is of type float. Similarly, we can write a output function which is tf.mul input 1 comma input 2. Now if we do with tf.session as sesh and print session.ses.run output comma feed dictionary input 1 colon 7 comma input 2 colon 2. So it will feed the placeholders input 1 and input 2 with values 7 and 2 and calculate the result of multiplication of input 1 and input 2 and print the value with the type float32. So 7 into 2 is 14, so the output which is coming is as 14. Placeholders in feed dictionaries in form of graphical form is shown in this figure, in which input 1 placeholder is fed with value 7 and input 2 is fed with value 2 and the output is printed on the screen. Linear regression in TensorFlow. If we import numpy as np and define np data of 100 with step dot point 1 and y is x data plus 20 into np dot sine x data by 10 and then scatter plot of this x data and y data, we will get a sine wave. Now linear regression in TensorFlow, if we are defining the samples as 1000 and batch size is 100, then we can use x data equal to np dot reshape x data comma and samples comma 1 and y data is equal to np dot reshape y data comma and samples comma 1 and then define placeholders for input which is of the form float and shape batch size comma 1 for x and similarly for y. After that we will define the variables which is weight tf dot variable which is initialized with random value and it is of the shape 1 comma 1. Similarly bias which is also constant initialization with value 0 and it is of the shape 1. Now if we define a function ypred which is tf.matmul bracket x comma w plus v, which is the simple equation of a linear line, and then we define the loss function as tf.reduce sum y minus y predicted square divided by n samples, then it will give us the mean MSE square, which is the mean square error, and then we can minimize this loss function to get the linear regression best fit line. Now we do the operation is equal to opt.minimize loss, and now if we do with tf.session as SESS and then sesh.run tf.initialize all variables and do sesh.run opt operation feed dictionary x with x data and y with y data, it will optimize